Today we're going to look at subtraction involving mixed numbers, and it's probably the trickiest thing we do that has to do with mixed numbers. The first thing we did in class today was we looked at regrouping and trading in a whole number for like fractional pieces. For example, and I'll try to model it as best I can. I don't have any fraction tiles here at home. If we had two whole fractional bars here, and then we had two 1/4 tiles. And so these are 1/4, these are 1/4, this is one whole, this is one whole. We talked about first taking this one whole and trading it in for 1/4. So how many 1/4 tiles would you trade in for one whole? How many 1/4 tiles make up one whole? And of course we look at the denominator for that, and since 4 is in the denominator, we know it takes 4 1/4 tiles to make up one whole. So if we were going to write this fraction the way it's modeled, you would have 2 and 2/4, and I realize that's not in simplest form, but for purposes of modeling we're going to leave that. And after we trade this in, we'd still have one of the wholes right here. But we've taken this whole and we've traded it in for 4 1/4 tiles here. The same as one whole, but now it is for 1/4 tiles. And then we still have our two 1/4 tiles over here. And so now the fraction I would write for what's modeled here is 1 6/4, because we have 6 1/4 tiles. I know it's an improper fraction, but I'm just doing this to model the way we are taking a whole unit in and trading it in for the pieces. And I forgot to bring something to wipe the whiteboard off when I sat down, so we'll just go ahead and do it the old-fashioned way. And the way this works is like this. First we started with just basic subtraction involving mixed numbers, and you might have 3 4/5 minus 1 2/5. And I asked the kids, rather than looking at the whole numbers first when it's subtraction, look at the fractions first. Notice that the denominators are the same because we need to have a common denominator to subtract. And then if the denominators are the same and the numerator is bigger, so that 4/5, we know 4/5 is bigger than 2/5, then we can go ahead and subtract the fractions. 4/5 minus 2/5 is 2/5. And then we just do the whole numbers. 3 minus 1 is 2. So we would have 2 2/5. Straight up, no problems with that, and everybody was fine with that. And then we mixed it up a little bit. We kicked it up a notch, as we say. And you might have something like this: 5 2/6 minus 2 5/6. And so, in keeping with what we just talked about, we would look at the fractions first. We notice the common denominator, so we don't have to worry about that. But we also then, when we go to subtract, notice that 2/6 is less than 5/6. So just like if I was doing subtraction and trying to take 2 minus 5, I can't do that. I have to regroup. In this case, I would have to borrow a group of 10 from over here if I was doing just straight subtraction. So we're going to borrow just the same way we would with regular subtraction. Only we're going to take one unit of these 5 holes. This is like 5 whole tile bars sitting here. And we're going to take one of these 5 and we're going to trade it in for, since there's a 6 on the bottom, however many sixths it takes to equal one whole. And since it's a 6, we know it takes 6 1/6 tiles to equal one whole. So we're going to cash in, trade one whole, so now we have 4 wholes, and we take the one whole, and it is now 6 sixths. So I take that 6 sixths, where I traded that, and I just add that to the 2 sixths. And so this becomes, just like we did at the very beginning, this becomes 4 8 sixths. And yes, it's improper, but we need that for our subtraction. Minus the 2 5/6, that doesn't change. Now we can subtract the fractions. So we have 8 minus 5 is 3 sixths. And then we just take this 4 minus 2, and it's 2 3/6. And of course, since we are halfway through the year in 4th grade, I would expect kids would notice this is an improper fraction, or excuse me, this is not in simplest form. It needs to be reduced. So it would be 2 1/2 when we reduced it. If they can get this far at this point, I'm pretty happy, honestly, if they can get to 2 and 3/6. But ideally, we'd like them to put it in simplest form. So let's do one more together. Then I can save this, process it, and send it a link to all you guys on YouTube so that you can look at this too. Because I know if you're like me, and I looked at this stuff with Eddie when he was in 4th grade, and it had been a while since I was in 4th grade. It was hard to remember how we did subtraction of mixed numbers, and it helps to be reminded. So let's say you have 8 and 2/10 minus 7 and 6/10. Same thing, common denominator, but 2/10 is less than 6/10. I'm going to have to regroup. So I'm going to cash in 1 out of here. I'm going to trade. I'm going to take 1 away. So this is 7. And 10 is on the bottom. And I know that 10/10 equals a whole. So I'm going to add then 10/10 to 2/10. And 10 plus 2 is 12. So now I have 12/10 here. So I'm not getting negative numbers or anything like that. I'm regrouping just like I would with straight subtraction. Then I'm going to do subtraction. I'm just going to take 12/10 minus 6/10, and I'm going to get 6/10. And 7 minus 7 is 0. I don't need to write the 0. It's just 6/10. And again, I'm in 4th grade. Near the end of the year, I realized that this is 3/5. But again, if we can get to this point, I'm feeling pretty good about it. So the answer would be 3/5. 6/10 reduced to 3/5. One more kind of tricky one that kind of threw the kids on the homework that I really meant to send this to you before I snuck out to Sam's game quickly after school today. But if you had something like this, and I can't remember the exact problem, but let's say it was 3 minus 2 and 5/8. It threw the kids because now we've got a whole number, and you can write it like this, or if it's easier and the problem's written this way, they can rewrite it in a linear fashion. It doesn't matter how it's written. It's the same thing. So this threw them because there's no fraction there. So what I tried to tell them is there is a fraction there. You just don't see it. And since we're talking about 8s, how many 8s do we have here? Well, we have 0. There are no 8s. Now they kind of knew what to do. Once they saw that fraction, they knew, again, we're trading. 3 becomes 2. And then I'm adding 8 8s for the one that I traded there. And so if I add 8 8s to 0 8s, of course, I get 8 8s. And then I just subtract. 8 8s minus 5 8s is 3 8s. 2 minus 2 is 0. So my answer in this case, and it is in simplest form, is 3 8s. I hope that helps. We're going to go over that again tomorrow and for a few more days on and off.